All right, let's take a quick look at this question, 7116. This is a question that people sometimes confuse with having to know a reaction pattern. They don't. What this question is really asking you to do is it's asking you to count the balls and then balance. Not even count the ball, just recognize what the balls are. And that really comes in right up here when you read the description. It says that purple spheres represent iodine atoms. Purple represents iodine atoms. And it says white spheres represent hydrogen atoms. So if you look at your picture, you can see you have two white spheres together. Well, if you have two hydrogen atoms together, what do you have? You have H2. They say that purple spheres represent iodine. Well, if you have two iodine atoms bonded together, like they're shown in this drawing, you have iodine 2. So that's before the reaction. So your reactants are going to be hydrogen, and we know they're in the gaseous phase because the molecules aren't associated with each other, right? There's space between them. So we've got hydrogen and iodide gas as our reactants. What's going to be our product? Well, if you look, all these pictures contain an iodine and a hydrogen. We know that iodine is a halogen and it forms negative, so it goes second because hydrogen likes to be positive as well. And again, we see there's space between everything, so we see they're in the gas phase. So we get our reaction simply by looking at the pictures. Balancing is done how you've always done it. You've got two hydrogens there, so you need to have two hydrogens on the second side, 2. You have two iodines on the reactant side, so you need to have two hydrogens on the other side. Hey, that 2 does it. So that's how you get your chemical reaction. You don't have to know a reaction pattern. In terms of which one of these drawings represents the after, they're really looking for a limiting reagent. Well, we've got our reaction, and we know it takes, for every one hydrogen we have and one iodine we have, we produce 2 hydrogen iodides. So in this box here, I have 2 hydrogens, right? And according to that chemical reaction we just wrote out, for every hydrogen iodide I have, I can produce 2 hydrogen. For every hydrogen I have, I can produce 2 hydrogen iodide. So if I have 2 hydrogens, I have enough to produce 4 hydrogen iodide molecules. In my drawing, I've got 3 iodines. Well, if I've got 3 iodines, then, according to my chemical equation I just wrote, for every 1 iodine I have, I can produce 2 hydrogen iodides. So I have enough hydrogen, so I have enough iodine to produce 6 hydrogen iodides. We're back to I forget whether I use bicycles or cars here. So we're back to our factory problem, right? Our limiting reagent. We have enough hydrogen to produce 4. We have enough iodine to produce 6. How many can we actually produce? We can actually produce 4. Well, so we come down to our pictures, and we see A has 4 hydrogen iodides, so it would be a potentially good picture. C has 4 hydrogen iodides, right? That's our hydrogen iodide. C has 4 hydrogen iodides, so it's still running as a valid response. B, however, has 5, so it's not valid. So we have to decide between A and C. The question becomes, in deciding between A and C, is we have iodine in excess, right? We have more iodine than we need to produce the 4-hydrogen iodide. Hydrogen is our limiting reagent because it produces the smaller number of products. So that's our limiting reagent. So we have excess iodine. So how much excess iodine do we have? Well, if we have enough hydrogen to produce 4 hydrogen iodides, then 4 hydrogen iodides would require us to use how many iodines? Well, according to my chemical equation, for every 2 hydrogen iodides, I need 1 hydrogen. So I would need 2 molecules of iodine to make my 4 molecules of hydrogen iodide. I have 3. I only need and can only use 2 because of my limited hydrogen. So I have 1 hydrogen iodide left over. So in my after reaction photo, I should still have 1 iodine left over. So that's why C is your correct answer. And that's how you work that problem. Now, this problem is a level 5 difficulty. It's one of the more challenging ones I've given you in the homework. So don't feel bad if you had to run to the video for this one. It's kind of expected, right? If every single question you get asked in this class is easy for you, then you're taking a class that's too easy.